This video is going to be over finding the direction angle of a vector. When we work on vectors, we can't forget our entire unit that was over trig and the unit circle. So whenever you're thinking about a vector, you always want to think about the vector as if it's imposed onto a quadrant plane similar to what we did with the unit circle. So whenever you're looking for the direction angle, what you're looking for is the angle between the x-axis and the terminal side of your vector. Something interesting that we should realize is when you're given a vector in the component form, that means you know the distance that was traveled in the x direction and you know the distance that was traveled in the y direction. So if we think about our unit that was over right triangle trig, we should realize that if we have two sides of our right triangle, side A and side B, we can figure out what the missing angle is using SOHCAHTOA. So in this situation, if we label our sides with side A being adjacent to the missing angle and side B being opposite, we know that we can use tangent because tangent of theta is equal to opposite over adjacent. Or I could use the letters that are given to me in the component form of the vector, which means tangent of theta is equal to b over a. So to write this out more clearly, because we're looking for angle, I can say direction angle, which is theta, is equal to tangent of b over a to the -1. Okay, so now that we have the direction angle formula, let's go ahead and work out two examples. On the left, we have a vector given to you in the linear format, which means that the number in front of I is the distance moved in the x direction, which is going to be the letter A as shown in component form, and then 7 in front of J is going to be the distance moved in the y direction, which is going to be the letter B in our component form. Over here we have another vector given to us just in component form, so we already know 4 is going to be A, distance moved in the x direction, and -5 is going to be B, distance moved in the y direction. Okay, so let's go ahead and work these out. I know A equals 3, B is equal to 7. I'm going to plug these into the formula. So theta is equal to tangent of B, which is 7, over A, which is 3, to the -1. Of course, you can use a calculator for this problem. And we get our final answer is 66.8 degrees. And now let's go ahead and move on to our second problem. We know A is equal to 4, B is equal to -5. We're going to plug this into the formula. Tangent of -5 over 4 to the -1. And this is going to give me tangent of -51.3 degrees. So just like we did whenever we had our trig unit, you always want your answer to be positive. So we're going to add 360 to our angle to make it positive. Let me zoom out a little to give myself more space. So -51.3 degrees plus 360 degrees is going to give us a final answer of 308.7 degrees. So following this video, there's going to be an IXL assignment over this exact same skill. So just make sure you complete that before Friday at 3 p.m. And I will have office hours tomorrow and on Friday from 10 to 11 a.m. via Zoom.